Just getting started here, and hopefully you guys are all doing well. Was anybody up for the snow this morning? It looks like it's stopped now, but it was definitely snowing earlier this morning, and don't know whether you guys were up in time to see that. But I'm going to go ahead and get started here this morning. Maybe we'll wait a minute or so for other people to join us. But what I want to do is I want to go over the problems that I assigned you guys, and I want to go over some new stuff for today. Okay. But just in case you weren't here or weren't looking online and all that kind of stuff, we have a quiz tomorrow. The quiz tomorrow will cover one of it'll just be one question, and one question that'll be similar to one of the problems on your homework. Okay, so maybe one of the ones that we're going to be going over today, or one of the ones that we went over in class on Friday. Okay, so quiz on Tuesday, quiz tomorrow. All right. So, any questions before we begin? Hi, Max. Hi, Jonathan. Hi, Jay Covers. All right. Any questions before we begin? Okay. If not, I think we're just going to go ahead and get started here. All right. So, your homework, just by the way, you should have already turned in your homework. Your homework is due 7:45 in the morning, and if you're turning it in late, then you're going to get points taken off, okay? Because I'm going to go through all the homework answers, and I want to make sure that you actually did it yourself. So make sure that you have turned in your homework already. I think I made that abundantly clear in Google Classroom, in Facts, and in my videos. But just in case, make sure you have your homework turned in. I'm going to go over the answers right now. So obviously, you're not going to get full credit if you haven't turned in your homework yet. So without further ado, let's just jump into number 5 here. Number 5 should have been probably the easiest one that I gave you guys. All right. There's a lot of extra information here. You don't need all that stuff. Okay. So it says if we dissolve 0.0749 moles of sodium cyanide in water to make a solution with a final volume of 235 milliliters, what is the molarity of the solution? Okay. So first of all, right, this very clearly right here is the moles. That's your value of N. This is the volume. That's that total volume, but we want to make sure our volume is in liters. So we're going to say your volume is actually 0.235 liters. All right, so then we plug it into the equation M equals N over V, and so that's going to be 0.0749 moles over 0.235 liters. And you plug that into your calculator. Let me just get our calculator out here. That's going to be 0.0749 divided by 0.235. Enter, and that's getting me a final answer of 0.319. Notice it's 0.318723, but we have 3 significant figures, so we're going to round off to 3 significant figures here because of that 3 significant figures for N. Okay, 0.319 moles per liter. Okay, so any question? You're so tired. Why are you so tired, Coffee Bean? Were you up late doing work, or were you up late watching stuff or playing video games? Just saying. Hopefully you guys can all adjust to this online school stuff. There's still the same amount of work for my class, so just make sure that you keep up with it and don't just spend all your time playing video games, which is probably what I would do if I were your age, but make sure you don't do that because you guys need your sleep. Sleep is super important for your immune system, right? If you don't get sleep, both. Awesome. If you don't get sleep, your immune system goes down, and it makes you more vulnerable to sicknesses like the flu and coronavirus. Anyway, so questions on this one? Max. All right. So if you dissolve, so we're going to jump down to number 6 there. I think number 5 was pretty straightforward. Number 6, if you dissolve 8.11 grams of potassium sulfate. Now you have to know what potassium sulfate is to solve this problem, right? So potassium sulfate is K2SO4. Remember, because potassium is K plus is positive 1, and sulfate is the SO4 2 minus ions. So because of the 2 minus, we're getting a K2 there. So probably we're going to need to go ahead and calculate the molar mass of potassium sulfate. But let's just go ahead and read the problem. So we got 8.11 grams. We can convert that to moles. of potassium sulfate in water is used to make a solution with a final volume. So there's our volume once again. So this 75 milliliters, that's going to be a volume of 0.075 liters. All right, so you should be pretty quick at converting milliliters to liters, just moving that decimal point 3 spots to the left to give you 0.075 liters. Okay, so yes, we're definitely going to have to calculate the molar mass of potassium sulfate in order to solve this problem. So let's go ahead and do that. Looking up at the periodic table, let's see if you guys can see this or not. We have potassium, right? And potassium is 39 point, let's just go ahead and do it. So you get potassium, you get 2 potassiums, that's going to be 39.0983. And we need to add to that sulfur, which is 32.066 grams per mole, right? Sulfur right up there. And then we have 4 oxygens, so plus 4 times 15.999, okay? And so we add that all up in your calculator to get the molar mass of potassium sulfate. This 2 times 39.0983 plus 32.066 plus 4 times 15.999. And we get this answer of 174.26 grams per mole. All right, that's the molar mass of potassium sulfate. Okay, so we can go ahead and get this out of the way for now. All right, so we are going to go ahead and use that number to do what? We want to calculate the moles, right? Because we don't have moles in the problem, and we know that molarity is number of moles over volume. So we need to go ahead and use that number to calculate the number of moles that we have. Okay, so we can do that using the 8.11 grams of potassium sulfate, and to convert it to moles, right? We're going to put our grams. So we start with grams. So we're going to put grams at the bottom. 174.26 grams. 1 mole on the top because we're converting to moles. So in your calculators, that's going to be 8.11 divided by 174.26. Okay? Or you can actually use the whole value for the molar mass, but I just rounded it off. So this should work fine. Okay? So that's going to be 0.04654. Okay? Moles of K2SO4. Okay? Last of all, we're going to take that number and we're going to divide by the volume because your molarity is number of moles over the volume in liters. And so that's going to be 0.0465 moles over our volume of 0.075 liters. So just hit divide by 0.075 in your calculator, and you're going to get this answer, 0.6205, but we're going to round it up to 0.621 because we have that 5 is going to round up, and we have only 3 significant figures. So 0.621 moles per liter. Okay? So we can see from both of these problems, we can calculate the molarity if we have the number of moles in the volume or if we have the mass in the volume. It's just a little bit more work if you have the mass in the volume. So let's pause there and see if you guys have any questions so far. Any questions at all? Good. I'm assuming no questions means that you guys got these right. So let's go ahead and jump down to the other problems that we've... Oh, wait. Coffee bean. All right. Off topic. I always want to thank you for your videos. You're welcome. They've helped me tremendously. Awesome. You even got an A on your exam. Awesome. You're welcome, Coffee Bean. All right. So let's jump down to number 7 on your homework. Okay. And we've got a problem which is a little bit different, but you guys already solved one of these before in class last time. Okay. So we have 27 milliliters. That's going to be our volume, right? And we're thinking, all right, 27 milliliters, that's going to be 0.027 liters. And we have 0.5 moles per liter of sodium hydroxide. How many moles of sodium hydroxide are in it? All right, now there's, like I said, there's a couple different ways that you could solve this problem. There's one way that I want to solve it in particular, but let's just go ahead and try this out. So you could solve it saying, okay, M equals N over V, and we want to solve for moles. So moles, that of course is N, and so we multiply both sides by V. That gets us N equals MV, right? Or, like I like to do, just because it's going to work out easier with our stoichiometry, we're going to go ahead and just use the molarity as a conversion factor, right? So molarity is moles per liter. It's a conversion factor between moles and liters. So what we're going to do is we're going to start off with this 0.027 liters. That's the initial amount, and we're going to use that molarity as our conversion factor. So we have 0.5 moles per liter, right? And so that's simply going to be in your calculator 0.027 times 0.5, and that's it. And so we have a final answer of 0.0135 moles. Liters over liters cancel out, and you're left with moles. Notice that if we had gone this route, it would be exactly the same, right? N equals M times V. This is V, this is M. So it doesn't matter whether it's N equals M times V or N equals V times M. It's still the same. Okay? So that's going to be your final answer for number 7. All right? Any questions on that one? Okay. We're going to use the same process down here, and we're going to add an extra step to it. Why? Because it wants us to solve for mass. Okay? So a little side note here, as I was looking at this problem, actually iron 2 nitrate doesn't really, it's not a stable compound. Maybe you could make it, but maybe not. The stable iron compound is iron 3 nitrate. So iron 2 nitrate, if you look it up, you're probably not going to find anything because iron 2 nitrate is not stable. Nitrate's an oxidizing agent. It oxidizes stuff, and iron would be oxidized to iron 3. So it wouldn't be stable as iron 2 nitrate. But anyway, let's go ahead and calculate the molar mass first, because we know that we're going to solve for a mass, so we're going to need to somehow convert from moles to grams. If you figure that out later, that's fine, right? You can go ahead and solve for moles and then be like, okay, I need to calculate the molar mass to calculate the mass, which is fine. But I'm going to go ahead and just start with it. Iron 2 nitrate, if it existed, that would be Fe2 plus, right? Because the iron 2, and nitrates NO3 minus, like that, right? So the formula of iron 2 nitrate is FeNO3 2. Okay? So to calculate the molar mass, we're just going to need our periodic table to do that. And that's going to be 1 iron, which is 55.845 grams. And we have, notice we have 2 nitrogens, right? Because we have 2 nitrates, we have 2 nitrogens. So that's going to be 2 times 14.007 grams per mole. Plus, we have, how many oxygens do we have? Just pause here. How many oxygens do we have in iron 2 nitrate? Anybody still with me? Anybody at all? 6. Yes, you got it right. All right, so there's 2 nitrates. Each nitrate has 6 oxygens, so it's going to be 2 times 3 or 6 oxygens. And that's correct, so it's going to be 15.999. All right, add that all up, and let's see what we come up with. So we have 55.845 plus 2 times 14.007 plus 6 times 15.999. And that gets us 179.853 grams per mole. That's our molar mass of iron 2 nitrate. Okay? Nice. Yes, you got it right. All right. So what we're going to do is I'm going to do this a little bit a different way. So what you probably would normally do when you're thinking of this problem, right? You have a volume, right? You have a molarity. We can go ahead and mark those, right? So we have our volume here. Volume is going to be 500 milliliters or 0.5 liters, right? We have a molarity there. Molarity is 1, making the problem a little bit easier. Mole per liter. And it's asking us for the mass, right? Which means we need to solve for n. So you could go ahead and solve for n, right? N equals m times v, and then go ahead and multiply by the molar mass to get the mass. Now, the homework, so I had a little question here. The homework is not just a completion grade, it's mostly completion grade, but I'm going to look at in terms of did you put the work in. Okay, I'll be able to see whether you actually did well or not. Okay, so back over here to the problem. We could do it that way. Instead, I want to do it more similar to this, and I want to set it up as a conversion. And it's going to be useful to think that way when we do stoichiometry. Okay, so the initial amount is 500 milliliters or 0.5 liters of our iron 2 nitrate. And we're going to convert that using the molarity to moles. And so that's going to be times 0.5 moles per liter. And we're not going to stop there. So we've gone from liters to, I made a mistake here. That's the molarity is 1. Sorry about that. Let's just scratch that out. Okay, let's start over here. Sorry about that. All right, that's going to be a volume. So our initial amount is 0.5 liters, and we're going to multiply that by the molarity, which is 1 mole per liter. And we're not going to stop there, right? We're going to go from liters to moles, and then we're going to go from moles to grams. Our conversion factor, well, what's our conversion factor between moles and grams? Our molar mass, right? So we can go ahead right away and write down our 179.853 grams per 1 mole, okay? And so this is going from liters to moles, and this is going from moles to grams, and that's going to be our final answer, what we want. So we are using, you can either use the formulas or you can use the conversion between liters and grams, and there are 2 conversion factors. One's the molar mass and one's the molarity. Okay, let's go ahead and plug that in your calculator to get the final answer. That's going to be 0.5 times 1 times the answer of our previous calculation, 179.853, and that's going to get our final answer right here of 89.9 grams here. Okay? All right. So guys, questions on that? Right under the green marking for number 8. Where did the 55? Oh, that is the molar mass of iron. So look in the periodic table. Look at the periodic table. You can find iron is 55.845. Okay? That's where you came up with that number. All right, other questions? Emphasize, are the homeworks completion? Okay, so the homeworks, like I said before, the homeworks are not entirely just completion grade. You need to complete them, but it's also for, partially correctness, but not completely, okay? So I want to see you guys actually putting the work into it. If you get something wrong, no big deal, but if I see you just like writing numbers down, you're not going to get full credit for that, okay? So, so back up to J covers, here we go. So the quiz is going to be 1 question based on the homework you're reviewing right now. Yes, the quiz is going to be simply 1 question. That's going to be one of these kinds of things. It's going to be more, let me just tell you right away, it's going to be more like the next problem that we're going to do, number 9, or one of the other ones we did before. It's going to be a stoichiometry problem involving involving some kind of molarity. Do you mind answering the question? Audie's question. Right under, yeah, I did. Okay, cool. All right, so let's go ahead and just on the quiz. You have a very generous time limit. You can use the entire period, but you will really not need it, okay? But because it's a quiz, we will be doing other stuff too. There's not going to be a live stream tomorrow, but there will be an assignment that you guys can do to work on. It's going to be a review for the test. We are going to be having a test on Friday, and we're going to be going over a bunch of review problems. I'm going to give you guys a sample test, all that kind of stuff. Okay? So hopefully this quiz will prepare you guys. Is the quiz on Google Classroom? Yes, the quiz is on Google Classroom. All right, other questions? Okay, so let's go ahead and jump into the next problem. Like I said, the next problem is going to be a little bit more important for the quiz, but they're all related, right? They're all about molarity, and we're going to be relating this molarity stuff to stoichiometry, bringing that all together. Okay, number 9, and I just want to make sure this is not bleeding through here. Okay, number 9, which I think is your last problem, right, on the homework, right, is we have a stoichiometry problem with molarity. And so like I said, that's going to be a lot more similar to what you're going to see on the quiz, some kind of stoichiometry problem with molarity. Let's do it. You have a large piece of zinc. So when you see large piece, you're thinking that you have an excess of it. You have more than enough of it. Okay, a large piece of zinc is placed into 150 milliliter solution of 0.25 mole per liter silver 1 nitrate, and they react to form zinc 2 nitrate and silver metal. So let's go ahead and write out the balanced reaction. So that's going to be zinc, which is a solid. We don't even need to write that. Plus silver 1 nitrate. So that's going to be AgNO3, both plus 1 and minus 1. They react. And what kind of reaction is this? Why don't you guys write down what kind of reaction is this? You can write that down in the comments. They're going to react to make, what's it say? Zinc 2 nitrate, so ZnNO3 2 plus silver metal. Yes, single replacement, you are correct. Single replacement. All right, so let's balance that. Is that balanced? No, right? So we got 2 nitrates here, 1 nitrate there. So we need to put a 2 there to balance the nitrates. That gives us 2 silvers, so we're going to put a 2 here to balance the silvers. Everything should be balanced now. Make sure you balance the reaction before you do the stoichiometry. All right, very, very important. So we write out the balanced reaction. What is the maximum amount of silver that reaction could produce? Okay, so maximum amount, we're thinking theoretical yield. We're thinking, what's our limiting reagent? But of course, this is not a limiting reagent problem because we already know that we have more than enough zinc. So we're just going to use the numbers that we have, 150 milliliters, and that 150 milliliters, so make a note, right? That's going to be our volume. So our volume is 0.15 liters, and that's going to be our molarity, that 0.25 moles per liter. That's going to be our molarity. Okay, so let's just go ahead and start this, and we can write this out as one long conversion, which I prefer, or you can do it step by step if you really want, but I'm not going to. I'm going to start off, write down the amount that we know, 0.15 liters, and we want to convert that to moles. Why? Because moles are going to be is the units that we need to go from one chemical to another chemical, right? So if we start off with silver 1 nitrate and we want to figure out how much silver we can make, we need to convert it to moles so we can go from one chemical to another chemical, okay? All right, so Luke, it's not up right now. Are you talking about the quiz? Of course the quiz is not up right now. If you're talking about the homework, I believe that any kind of homework your homework is up right now. But anyway, so the quiz will be up tomorrow morning, right? It'll be up right at the beginning of class. You'll have whatever, 45 minutes to do it, and that's it. Okay, so back over here. So 0.15 liters, that's the amount you start with. We're going to convert that to moles. And how do we do that? Our molar mass is our molarity is our conversion factor. So that's going to be 0.25 moles per liter. That's going to convert us from, I should have written down the chemical here. So this is silver 1 nitrate. So we have 0.15 liters of silver 1 nitrate. We're going to convert that to moles. Next, we want to convert that from moles of silver nitrate to moles of silver. And the way we're going to do that is the balanced reaction. So for starting off with silver 1 nitrate, we need to put that silver nitrate at the bottom here, AgNO3. And we have 2 of them from the balanced equation. And we want to convert that into moles of silver. So we're going to put 2Ag at the top. Okay, now pause here. I got a question. Mr. Ketz, if I did something wrong, can I resubmit? No, this is a quiz. Just don't do something wrong, okay? And yeah. Sorry, it's not homework, okay? So homework you can resubmit, quizzes you cannot resubmit, okay? All right, back over here. So, last of all, we're going to convert from moles of silver to grams of silver, and so we need to put the molar mass of silver right here, okay? And so we're going to put, on the top here is going to be the molar mass of silver, which is 107.87 grams is 1 mole, okay? And so finally, we need to convert this into grams, and we're going to go ahead and do this whole conversion together. So we have 0.15 times 0.25 times 2 over 2, which is really just 1, times 107.87 to get our final answer here of 4.045. We're just going to round it to 4.05 grams of silver. Okay? So let's just pause there and see if you guys have any questions. All right. So back up here, you think he means the homework. I'm pretty sure I did post the new homework. Okay, so it's up on Google Classroom. It's 8.7. It's up there. Okay. Okay, he said you can resubmit the homework. Yes, you can resubmit the homework, but not quizzes. Okay. Yeah, you can resubmit that. So hopefully you guys can figure that out. If you made a mistake on the homework, don't worry about resubmitting that. Okay. You can resubmit only if it's before the deadline, right? So the deadline is before class, 7:45 in the morning, and so make sure you're welcome to resubmit before then, but after the deadline, you can't resubmit. Okay. Cool. Thanks. You are so welcome, Leo. Yes, you are. All right. So back over here. That is our final answer, and that is what your quiz question is going to look like. Who knows? It might be a different kind of problem. It might be a double replacement reaction, but it's going to be some kind of replacement reaction, probably because most of your other reactions are not involving aqueous solutions. Okay? So this is going to be kind of like your quiz problem. But I do have some new stuff for you guys. So one new thing that I want you guys to do, okay? One new assignment. Wait, can you go over how you found the molar mass? Yes, I can go over how I found the molar mass. In this problem, super easy, because this is the molar mass of what? It's the molar mass of silver, the molar mass of the final thing that I'm making, right? The molar mass of silver right there, okay? Always, 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 right? You're going to find that these two things are going to correspond to each other. This is the molar mass of this. And so silver, you simply look up on the periodic table, and that's it. So periodic table says silver, 107.87, done. No calculations needed. Okay. There are some molar mass calculations that you guys had on the previous problems, which you guys can go back and look on the video. So if you're live streaming it, just once you're done, you can just go back and I went through how to calculate every single molar mass. You can go back over that. Okay. All right. So any other questions on this quiz tomorrow? One problem. Again, guys, this quiz is going to be open notes. You guys are so lucky that you can do this at home. And it's open notes quiz. You can look up at the previous stuff, right? The only thing that I'm restricting you by is I'm going to say you cannot ask each other how to do the problem. That would be cheating. You cannot ask someone on the internet, how do I do this problem? That would be cheating. But otherwise, you're welcome to look in the book. You're welcome to look at your homework. You're welcome to look at any of these problems, and it will help you out, all right? That doesn't mean don't worry about it because you have a time limit, and so you're going to make sure that you finish it in time, and you do have a test coming up. but you're welcome to look back at anything during the quiz, no problem. Okay, so without further ado, let's go ahead and start the new stuff for today. You're going to find this new stuff up on your homework in Google Classroom already, and really there's no new concepts here. What we're doing is we're combining together the concepts that we've done already. We're combining together the ideas of molarity and the ideas of previous things that we've done before, which is your percent yield, your limiting reagent, all that kind of stuff put together in one kind of problem, which, yes, you will see on the test, but it won't be on the quiz yet. Okay, so why don't you guys look at the problem, and we'll do it together. Like always, we're going to start off with the balanced reaction, okay? And the balanced reaction tells us a double replacement reaction. You have calcium bromide, calcium, of course, let's just write it up here. Calcium being 2 plus because it's in the second column, bromide being 1 minus. Silver, it tells you that silver is a positive 1, and nitrate is NO3 minus, okay? So let's go ahead and write the formulas down. So because that's plus 2 and minus 1, that's going to be CaBr2, and that's going to be AQ. Plus, we have silver nitrate, AgNO3. And I didn't really need those parentheses because it's just 1 and 1. And that is also aqueous. Remember, double replacement is always going to be 2 aqueous solutions that are mixed together. And you're going to put calcium with nitrate and silver with bromide. So calcium and nitrate is going to be CaNO3 2. The 2 because calcium is a positive 2 charge, right? So you need a 2 for the nitrate. That's going to be aqueous, okay? Because you know, based on your solubility properties, that all nitrates are soluble. Plus silver bromide is going to be AgBr, which is going to be your precipitate. Why? Because bromides are all soluble except for silver and lead, and that's clearly silver. Okay, so that is not balanced. Let's go ahead and balance that before we go any further. We have 2 nitrates here, and so we need to put a 2 in front here. That's going to give us 2 silvers and 2 bromides. So we put a 2 in front of there to balance it, and everything else is nice. Don't forget to balance your reaction. You must balance the reaction, or else your final answers are going to be wrong. So let's break this down. We have a bunch of questions, right? It says after the reaction, he's going to collect this. We've got these different concentrations. What's the limiting reagent? What's the actual yield? What's the theoretical yield? The percent yield? So a whole bunch of questions going on here. And we have a whole bunch of numbers. So we need to just make sense of everything as we go along, okay? And so first of all, when you see he collects that is going to refer to your actual yield. Anytime you see that, you can identify that as the actual yield right away. Okay, so your actual yield is, let's just write it down. Actual yield is going to be 3.11 grams. Okay, what is the limiting reagent? Now, to get the limiting reagent, like before, we're going to need to do 2 different calculations. We're going to need to calculate how much of our product you can make from this and how much of the product you can make from that. And the one that can make the smallest amount of product will be the limiting reagent. So let's go ahead and set this up. All right, so Jack mixes 35 milliliters. I'm going to write that down as 0.035 liters of what? Of calcium bromide, CaBr2. All right. And it tells us the molarity right there, 0.4. So this is going to be 0.4 moles per liter. Okay. And we want to figure out how much of the products we can make. Now, which product are we going to solve for? What do you guys think? Which product are we going to solve for this problem? Because that's going to make a difference when we put these things in here and we figure out what chemical goes here and here. We want to know which product is going to solve for. So what do you guys think? Which product are we going to solve for and why? I'm actually asking a question. This is not rhetorical. I want you to actually answer this. Which product are we going to solve for? Are we going to solve for calcium nitrate, or are we going to solve for silver bromide? Silver bromide, you are correct. And the reason is because it says he collects 3.11 grams of silver 1 bromide. Okay? You're going to solve for the chemical that you have the actual yield for. And you're going to do that twice for both of the reactants. Okay? So because that's the actual yield, we're going to put our 2 AgBr here at the top. Very good. And next, we're going to put on the bottom whatever you started off with. So if you start off with calcium bromide, we're going to put 1 CaBr2 here on the bottom. Last of all, we want to calculate this in grams. So we're going to put 1 mole on the bottom, convert moles to grams. And that means we need to get the molar mass of silver bromide, which once again, I'll show you guys how to do that right here. So let's just move that over a tad. So silver bromide is 1 silver and 1 bromine for your molar mass calculations. You do not include those big numbers, okay? You do not include coefficients out in front. So silver bromide is simply 1 silver. So that's going to be, let me see here, where's silver? Right here. So it's going to be 107.87 grams per mole plus 1 bromine, which is 79.904. Add them together, and we'll get the molar mass of silver 1 bromide. Let's just plug them in right now. 107.87 plus 79.904, and that gets us 187.774 grams per mole. Okay, so that's our molar mass, which we can use in our conversion. And I'm kind of running out of space here. 187.774 grams. All right. And so let's go ahead and do this calculation here for calculating how much silver bromide you can make from the calcium bromide. And I will type it in here, 0.035 times multiplied by numbers on the top times 0.4, divide by numbers on the bottom. So times 0.4 times 2, you can basically ignore the ones, times 2, and then times that 187, which we can just use what we had previously. So I'm going to do a second answer there, and I'm going to get a number. Look at that. That is the amount that we can make. So I'm going to write this a little bit sideways here so we can fit it in. 5.26 grams of silver bromide there. Okay? So are we done? No, we're definitely not done. We need to calculate this both for the calcium bromide and for the silver 1 nitrate. So let's go ahead and jump into the last part of this. And that is how much, let me see, how much silver nitrate do we have? We have 48 milliliters. So that's going to be 0.048 liters of AgNO3. Okay. Our molarity is going to be our conversion between liters and moles. That's 0.5 moles per liter. And then the middle part is going to be converting between silver nitrate and silver bromide. If we start off with silver nitrate, we're going to put 2 AgNO3 on the bottom, and we're solving for silver bromide. So it's going to be 2 AgBr on the top. Okay? And then, last of all, we want to convert that into grams. So once again, we're going to need the molar mass of silver bromide, and that's going to be 187.774 grams per mole. Notice, before I do the calculation, notice what's going on. Notice that the tops here are the same. So we got silver bromide and the molar mass of silver bromide. We got silver bromide, and we got the molar mass of silver bromide. Notice that that's the same because we're solving for the same product, which we should. You must always solve for the same product when you're determining the limiting reagent. Okay, so let's go ahead and plug that in, get a number. It is 0.048 times 0.5 times 2 over 2. We can just ignore that because that's just 1, and then just multiply by the molar mass, 187.774, to get an answer of 4.0 I'm going to round it up to 4.51 grams of silver bromide. So I'm going to ask you guys, what is the limiting reagent and what is the theoretical yield? Because they're on the paper right now. All right, so question for everybody, what is the limiting reagent? All right, we're running out of time here, so I'm just going to go ahead and answer. Maybe somebody already answered. But the limiting reagent is the reactant that makes the smallest amount of product. So this silver nitrate is the limiting reactant or limiting reagent. Okay? And the amount of product it makes, the smaller amount of the two, is the theoretical yield. Right? That's going to be our theoretical yield. Right? That's the maximum amount of product you can make. As soon as you make 4.51 grams of silver bromide, you will run out of silver nitrate, so you cannot possibly ever make any more. Okay? So last of all, the question also asks us for the percent yield. Percent yield is simply going to be the actual, right, divided by the theoretical, all times 100 to make it into a percent. So let's go ahead and see what we have. The actual, we already said way back up there, is going to be 3.11 grams divided by the theoretical of 4.51 grams times 100 to make it into a percent. And so let's see what we get in the calculator. That's going to be 3.11 divided by the previous answer of 4.506. I like to use whatever numbers in my calculator rather than using the rounded off number. It works a little bit better. That's going to get me 69. Okay, 69.0. 69.0%. Our final answer of the theoretical yield. And that is pretty much it for today. We're pretty much all out of time. So any questions before we just cut out? Nice. All right. Well, hopefully you guys are all doing well, staying safe, getting sleep, enjoying your time at home. No, seriously, enjoy your time at home. And I will see you guys tomorrow for the quiz, open notes quiz, but make sure you know what you're doing. You're welcome. Have a great rest of your day. See ya.